Medical technology devices are produced throughout the world. 3D printing has proven to be the most efficient technique for this endeavor. Aside from fast and cost-effective production, medical devices must expressly meet the highest quality standards. igus GmbH is a worldwide manufacturer of machine elements. On location, Tom Krause and Ulf Hottung explained the steps it takes to produce a medical device and told us what makes the materials of igus so unique. Here at igus, we manufacture special and general wearing parts that always contain our solid lubricant in plastic, allowing the customer to guarantee lubrication and maintenance-free operation over the expected service life. This also applies to 3D printing, where we also use materials that include solid lubricants. High abrasion resistance is achieved by integrating solid lubricants into the 3D printing materials that are between 6 to 50 times more abrasion resistant than conventional 3D printing materials. igus offers 3D printing processes in laser sintering using the Iglidur i3 and Iglidur i6 materials, as well as printing filament processes with more than 6 materials. Laser sintering is the preferred method for medical devices. Laser sintering is the most commonly used method in medical technology because it provides greater resistance, achieves a higher accuracy of components, and the component cost is lower since the laser moves about 100 times faster than the print head in the FDM technique. After their production is completed, medical devices are used in various fields. 3D printed components by igus are generally applied as a complete unit. They're used in laboratory equipment to simplify function or to facilitate cost-effective production of smaller quantities, as SLS pressure parts, or as filament components made with special materials like our Iglidur C500. They range from being a prototype to a tool-based material, as well as a later serial production component in nearly all applications. From concept to finished product, the manufacturing process varies in complexity depending on the customer's preferences. Customers can use our online tools to upload a file version of their component to our computer and review material alternatives and component costs at the same time. If the design process is complex, the customer can coordinate the design data with igus. The next step typically involves the production of a 3D printed tool to use a specific igus plastic option. This element is validated and subsequently made as a serial steel tool. In the igus test laboratory, the products are tested on their specifics such as service life, wear and coefficients of friction to guarantee safety and the best quality. Depending on customer wishes, the behavior of plastic materials influenced by temperature, chemicals or motion parameters are also added to the mix. They attest to the service life of the products. Ultimately, igus offers the customer the best material alternative. Looking ahead, igus is already proactively planning the next step of development in additive manufacturing. The next steps of development we want to take is to develop new materials to cover other application areas such as high-load applications. Special materials with special requirements for medical technology are also a conceivable option to allow us to cover more implementations in this sector. We're also working diligently on automating the overall process to be able to improve cost structures and offer larger quantities, while still being competitive compared with other manufacturing methods.